Hi, Calculus 1 student. So this is a limit that pretty much combines two techniques you will see as I will cover the video, and also is talking about the fact that a limit could have a parameter inside of it. So we consider this limit, and there's the first question is what's the variable and what's the parameter? So this is important to distinguish. So the variable, what I'm meaning is the variable of the function, right? So what the input of the function is. And in this case, the input would be just h. So we consider a function that has as a variable h, and we're taking the limit of the function as the variable h is approaching 0. So the variable is h. Let's write this down. So variable h, and the parameter is a. So a is actually considered a constant in this limit. One thing that is particular is that we're only considering a to be greater than 0, and this is because otherwise this limit will fail to exist. So the parameter is a. So in other words, the limit doesn't depend on a at all. Well, actually, the result will depend on a, but a is not approaching a specific value. It just stays as is. So it's a constant as far as this limit is concerned. The variable of the limit is h. So now let's evaluate the limit. So I'll just start recopying here. The limit as h is approaching 0 of 1 over the square root of a plus h minus 1 over the square root of a. All of this being divided by h. So the first thing to do is to do direct substitution, as we have seen a couple of times in class. And what we get out of this is quite simple, because we have like 1 over square root of a minus 1 over square root of a. So the top gives 0. And the bottom also gives 0. Now, one thing you should notice is that there's actually two problems in this limit. And one is a little bit severe than the other. The first big problem is that there's fractions. There's like inner fractions. So let's put it this way. So problem number 1, okay, that there is inner fractions. And we saw what was the solution to this problem. It is to multiply by the least common denominator. So multiply numerator and denominator of the main fraction, right? By the least common denominator. So in other words, yes, so the least common denominator here is actually quite easy to get. So the LCD here, square root of a plus h is part of it, and then square root of a. So that is the least common denominator. So actually, I will write the equal sign here, because here I'm missing space anymore. So this will be the same as the limit as h is approaching 0. And now, okay, so first I will rewrite the limit, a plus h minus 1 over square root of a, all of this divided by h, okay? Now, don't forget, there's implicit brackets, and you multiply by, and I will actually put it a little bit more up, a plus h, so square root of a plus h times square root of a. But don't forget, that you need to also multiply the denominator by this. All right, so what's gonna happen? Remember that you need to distribute this, okay? Here, as you can see, the a plus h will cancel the a plus h that is over there. And we will be left with square root of a for the first term. For the second term, we have like the square root of a here. That cancels the square root of a. So what is left at the top is simply the square root of a plus h. So let's write here minus square root of a plus h. And then the denominator becomes h. And then as you can see, nothing cancels over here. So let's just go square root of, and actually I will keep the green just for now. So square root of a plus h, and then square root of a. Okay. Now, and I will probably continue the limit above because this is where you hit the problem number 2. And I will actually, have more space here. So problem number 2. Okay, remember that when you're doing limits, you want to cancel a redundant factor that is giving 0. Okay, so in the denominator, this is straightforward. It's h. So in other words, you know already that what you want to cancel is h. But the problem is that everything is kind of stuck inside the square root here. So this is what we're unhappy about. We cannot factor this in order to extract a factor of h. So here we go. Problem number 2 is that we can't factor the square root of a minus square root of a plus h. But fortunately, we already know how to handle it. We're going to rationalize it. So rationalize. So I'm going to continue the limit over here. I'm going to erase the statement and the question 1. So where's my eraser? It should be nearby. Here you are. So it means that we have the limit as h is approaching 0 of square root of a minus square root of a plus h divided by h square root of a plus h square root of a. And what we're doing is we're multiplying the top and the bottom by the conjugate of this. So square root of a plus square root of a plus h over square root of a plus square root of a plus h. And don't forget the outcome. Don't forget, for example, that there's implicit brackets around these members. So don't forget one thing. At the bottom, we're not doing anything. And the reason is because we already have the problematic factor. So we want to cancel something with it. So all of our work is going to happen at the top. So at the bottom, we can already write the result. We're going to have h square root of a plus h square root of a. Okay? And then we also have the square root of a plus the square root of a plus h. So we also have that. But the top turns into the difference of squares. So it turns into something squared minus something else squared. And obviously that's something and that's something else are the two terms. So square root of a and square root of a plus h. Now, look carefully. We're going to square first. So we're going to get a, and then we're going to get here bracket a plus h. And then a big denominator as usual, but this shouldn't scare you. Okay? And now we almost won, because look, what's happening is that these a's cancel and we get at the top a negative h. So we have like negative h here divided by h, square root of a plus h, square root of a, square root of a plus square root of a plus h. So now is the time to cancel the problematic factor. Now you see it appears at the top. This is why we did all this algebra, in order to be able to cancel it. So once we cancel the h, this is the time to try again direct substitution. So in other words, let's just replace directly. We have negative 1. Then we don't have any more h here. We have the square root of a. So square root of a plus 0, in other words. So note here that all these h's are approaching 0. So we have square root of a times square root of a times square root of a plus square root of a. And your job is simply to simplify this at this point, because look, square root of a times square root of a gives you a. And then you have twice the square root of a here. So it means that the final answer is negative 1 over 2a square root of a. There you go. I hope this helped, and see you next week.